Okay, good evening everybody. We are live again. It is 10:30 p.m. in the evening, and let's continue. So we need to learn recurrence relations. So what will we do is this Copilot is kind of less intelligent. So we will take a screenshot of this question and we will copy it and we will go to ChatGPT. Yeah. So I need to be able to solve this question. Don't assume any prerequisites and solve it. I mean, teach me the ways and the whole philosophy of recurrence relations and every other theory needed to solve this one. Okay, what is a recurrence relation? In terms of its previous values, okay. The cost of n depends on the cost of level n minus 1 repeated many times. In algorithms, recurrences describe recursions, divide and conquer dynamic programming. Okay, so we need the tight bound. How fast does the recursive part grow? How fast does the added work grow? Which one dominates? Repeated expansion unrolling. Okay, replace t of n minus 1. Okay. Pattern number is 2 power k t power n minus k 2 power n. Okay. Stop at base case. When k becomes n, okay. 2 power n since t of 0 is equals to 1. Okay. Quadratic amplification. It is actually easy. Kind of understood that one. Let's all do more problems, shall we? We see the oh my god. Claude Opus. Gemini 3 and GPT. So Claude is dominating. So it proved that Google servers I mean, you have never heard of anthropic, right? You have never heard of it. So this is t of n is equals to 3tn minus 1 plus n to power n, and t of 0 is equals to 1. So get t of n minus 1, 3t n minus 1 minus 1 n minus 2 plus n minus 1 into 2 power n minus 1, and t of n minus 2 will be 3t. If you substitute, alright, so n minus 2, that will be n minus 3 plus n minus 2 into 2 power n minus 2. That's it. No, let's see. So this is what he got. 2t. Oh wait. You know what? Let's solve this one actually. Given t of n is equals to 2tn minus 1 plus n power 2 power n, and you need to get t of n minus 1, that is 2tn minus 2 plus n minus 1 times 2 power n. So now t of n is equals to, right, put everything here. I see 2tn minus 2 plus n minus 1 to power n plus n into 2 power n, that is 4tn minus 2 plus n minus 1 into 2 power n plus, oh wait, what? Yeah, n minus 1, that will be 2 power n plus n into 2 power n. Okay, that will be 4tn minus 2 plus n minus 1 or plus n into 2 power n. Okay. Expand once more. So get t of n minus 2. You need this one. So 2t n minus 3 plus n minus 2 into 2 power n minus 2. So let's put it over there. 4 into 2t n minus 3 plus n minus 2 to power n minus 2 plus n minus 1 to power n plus n into 2 power n. If you do this, 80 n minus 3 plus this is going to be 2 squared. So this cancels out, n minus 2 into 2 power n plus n minus 1 into 2 power n plus n into 2 power n. So after k expansions, it will become, right. So you got this one and this one. So after 3 expansions, it became this. So it becomes 2 power k t n minus k plus n minus k 2 power n. Okay, so it is n minus k minus 1 into 2 power n plus n into 2 power n. So what can you do? 2 power k t power n minus k. So if you take 2 power n common, n minus 1, something like this. So since we know t of 0 is equals to 1, it will be 2 power n plus 2 power n into n plus 1 by 2. So take 2 power n common, 1 plus n into n plus 1 by 2. N square. How did you get n square? So that's why you need to know series. Yeah, I know that. Okay, n square is the highest term. Got it. So we just need some practice, that's it. Let us, solve two more recurrences. 3t n minus 1 plus n power 2 and t of 0 is equals to 1. So that is tn, and if you do tn minus 1, 3t n minus 2 plus n minus 1 into 2 power n minus 1. So then t of n will implicitly become 3 into 3t n minus 2 plus n minus 1 2 power n minus 1 plus n into 2 power n. So that is t square tn minus 2 plus 3 n minus 1 into 2 power n minus 1 plus n power 2n. Let's do one more rolling just in case. 3t n minus 3 plus n minus 2 into 2 power n minus 2. Okay. And now 3 square t into 3t n minus 3 plus n minus 2 into 2 power n minus 2. Yeah, you just substituted this here. Plus 3n minus 1 to power 8. 2 power n minus 1 plus n power 2n. So for n is equals to k, it will be 3 power k t. Now if you look at this term and this term, right? 3t n minus k plus Okay, you did not expand that one. My bad. My bad, I did not expand that. Firstly, it is kind of small over here. Wait, it will be 3 cube. Yeah, so 3 cube Tn minus 3 plus 3 square n minus 2, 2 power n minus 2 plus 3n minus 1, 2 power n minus 1 plus n into 2 power n. For n is equals to k, you get 3 power kt into n minus k plus so 3 square and t, it will be k minus 1 n minus k minus 1 2 power n minus k minus 1 plus 3 power k minus 2. Okay, I can see the pattern now. At the end, what is it? N. That is a sweet little pattern. Wow. Wow, I mean. So for ith term, k minus I, 3 power k minus I n minus k minus I, 2 power n minus k minus I plus I. Okay. Pattern recognition, partial structural clarity. consolidation ladder. Yeah, it is enough for this question. We did the research and we did this one. Did we do this one too? Yeah, we did that one. Now we are here to do this one. You know what? We will do our rough over here. Undirected, unweighted, 100 vertices. Number of edges in the shortest path between U and V. Maximum number of DUV so is 30. Breadth first search. So let us consider this example because why not? So this length is given as 30 and what will be, no, this is not 30. Actually this length and this length, let's say. So this length is 30. The height of T is exactly alright. If we do something maybe like this. The maximum distance is 4. Yeah. So if you kind of do BFS, okay, by the way, I have already solved this question, so I know what this question is kind of talking about. I guess our half an hour for algorithms is about to be over. So any breadth first search, why not this? Let's say this is a breadth first search. This is level 1. This is level 2. So you cannot say exactly 30 because if you BFS here, it will be 1. T is what? The height of the BFS. No, you cannot say that if you take the center. Yeah, if you take the center, it cannot be smaller than at least 15. Max 30. So BFS, if the best vertex is taken, should be At least half of that, and that is a 2 mark question. So the analysis really pays off. The maximum value such that B and C, the maximum so between the nodes B and C, wait, the maximum value of X such that the edge between B and C is included in every minimum spanning tree of the graph is okay. So if it needs to be always included, let's fix that one. Okay. Minimum spanning tree. If it is 1, it will always be included. So it is 1, it is always included. And now what? It is 3, it is always included as well. And now, if it is 6, if it is 6, then AD will be included. So we need it to be included, so it should be 5. Yeah, it is 5. And our analysis is correct. In a double hashing scheme, I have studied this double hashing scheme. 1 plus k mod 7 are the auxiliary hash functions. The size m of the hash 11, the hash function of the ith probe, and the open address table. The slot at which 24 gets stored is hashing. So double hashing means this 63 mod 11, 55 and 8. And 50, that is 44, and that is 6. And 25, that is 22, that is 3. And 79, that is 77, that is 2. And 67, that is 66, that is 1. And 24, that is 3. So then 1 plus k mod 7. So 24 mod 7. 7 3s are 21. 3, that is 4. Okay, so if the primary hash is not working, Nice. So if you look at this, I is equals to 0, 24. Yeah. So I iterable or looping variable. Alright. So 3 plus 4, 7. Wait, what? 24 mod 11. 24 mod 11 is 2. Idiot. Not 3. So 2 plus 4, 6, that is a collision. Yeah, 2 is a collision, 6 is a collision, and 2 plus 8, 10. Yeah, I did it already, that's why I kind of know what's going on. 31 minutes, enough of algorithms. Let's just check how many algorithm questions we have completed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 questions and 25 data structure questions. That is already 36 total questions. We can we can kind of crack 50 if we want today. Wow, the amount of progress that you will do if you really work hard like this is just awesome. Theory of computation, 7,000 questions. So average of 8 marks. I don't want to lose that. I have studied some theory of computation, by the way. Okay, this is the set of alphabets, I think, and x belongs to okay, every possible combination, and number of occurrences of a in x. Which one of the following options define regular languages? So I did this one. No, I did not do this one. Okay. Regular language. You know what that one should mean. So A can occur any times, B can occur any times. Okay, regular language is something that can be described by a you know yeah, finite set of states. Yeah, I have studied all of this. We just cannot compare. This one is not regular. What is a regular language? Guess we will solve 10 more questions today. finite automata, regular expressions. So accepted by DFA, accepted by NDFA, type 3 grammar in the Chomsky hierarchy. So yeah, any number of m's followed by any number of n's don't need track of mn. So there is only one stack. You need to keep track of m, you need to keep track of n, so you cannot decide number of states. Yeah. So a DFA can count A's mod 7 and B's mod 9 using separate counters and track them using a product of states. Classic non-regular condition. DFS cannot compare counts of two different symbols. Right. So you just need a bit of theory for that one. So these are the alphabets. In product B, product of symbols in X modulo 7, we take product Z epsilon 1, okay, epsilon is a null string. So 1 times 2 times 4 mod 7 is equals to 1. So that is 6 mod 7, sorry 8 mod 7, that is equals to 1. Define language. So product function will always return 2. Kind of did this one actually. 1 mod 7 is 1, 2 mod 7 is 2, 3 mod 7 is 3, 4 mod 7 is 4, and again you will have 6 mod 7 is equals to 6, and 4 twos are 8 mod 7 is equals to 1 again. 12 mod 7 is equals to 5, so you got 1, 2, 3, 4, 5, 6. So I don't think you cannot have 0. because 2, 3, 4, it should be cannot produce multiple of 7. So you need to have something like 21 mod 7 is equals to 0. But 21 can never be produced by alphabet. Deepak sir ने explanation दिया है इसका. He did not do engineering mathematics. Hemant Reddy. Let's say yes, 2022. Yep, there are PYQs. Mhm. Yep, that is true. Anyways, we will continue. So, push down automation or PDA. Alright, regular language. Let's see. Is this all? All regular languages are accepted by deterministic push-down automation accepts deterministic context-free languages. Regular languages are subset of and PD is more powerful than okay. Yeah, I kind of read that. I mean, I read only a part of it, but still I understood. G1, G2, B, pointless comment. G1, G2, B, context free grammars, and R, B, a regular expression for a grammar denote language is decidable. Okay. G1, G2 are CFGs, context free grammars, and R is a regular expression. Why do you need R? Okay. The language accepted by grammar is equal to the language of regular expression. If they are CFGs, decidability on equality is not possible. So grammar can be compared to a regular expression. C okay, we did not study understandability. Halt halting problem. The universality problem is undecidable. The CFG equivalent, okay, PCP. CFG universality. Context free Raman universality. I did not study undecidability, but I understand what that guy is trying to say. Okay, context free grammar, recursive language, regular language. I think I can do this. Context free grammar. If a CFG and CFG is combined, the resultant Regular language. CFL. Hmm. So you need to know more theory in order to solve questions like this. I will complete reading that book. CFG. So yes is A, B, A, B, B. A is A or A, B or B, B. That seems like Chomsky's, type 2 something, something like that. Which one of the following languages is accepted by grammar? So A square B power n. So this is basically B power n, and this is basically A power n, and that is basically A square B power n or A power n B square. So A square B power n, A power n B square. That will be accepted. A power n, no. A power n, no, this is not. A power n B power n, no. You can just get this derivation. A is your answer. Yeah, it is. It is easy one. Okay. A regular language is accepted by NFA with n states. Which one of the following statements are false? L may have an accepting NFA with less than n states. Right? That is the concept of minimization. So that is true. L may have an accepting DFA with less than n states. Minimization, yes, might be there exists a DFA with less than or equal to 2 power n states. Yes, that is minimization. Every DFA, every DFA that accepts L has greater than 2 power n states. No, by brute force itself, you have only 2 power n states. So D is false. Even if it is at multiple select. An NFA not required to be minimal. Unreachable, redundant, or equivalent states. L may have an accepting DFA. So the standard conversion of NFA to a DFA can result. Yep, got it. We did the good analysis. So that study actually paid off. Any number of A's, any number of B's. And beta is equals to, okay. Nice, right? So you need to look at if they are regular languages or not. Yeah, I have already learned about this one. I mean, I kind of identified a pattern. So alpha, beta, alpha is saying anything followed by anything followed by anything. That is basically closure. So here, sum is any A and B, the same number of A's. So it is not regular, not RL. L2 is not RL. L1 is RL, but L2 is not RL. B is your answer. Wait, what? We did it reverse. Oh wait. Yeah, we got the idea. Ah, same thing as first. We have to match the starting and ending part string. A B L2 here is regular. A plus B A plus, okay. Writing as yeah. So let's see this explanation. Alpha is yes, it is. Okay, okay. Yeah, now I understood better. Consider the following two languages. Yeah, I did this one as well, actually. M and N are natural numbers. So CFL. What is a context free language? So let's do a power 5 and you will get b power 5 and c power. So how to check if a language is CFL or not? Pumping lemma. Yeah, so you can a power m, b power m, c power m, and c power n. So this is all good. Just one more that works. DFA. Okay, we should be able to do this since it is an easy one, and I kind of study the transition states a lot today. The set of all strings containing an even number of b's. So let's do a run. It can contain A and B and B's and A. B. A. B. If it go there as well, B. A. B. Yeah, this is okay. I mean, the set of all strings containing the pattern B, A, ending with the pattern BAB, that is correct. Not containing the pattern ABA. Can you generate an ABA at least to prove this? So A, B, 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 A, B, A. So A, B, A. Alright, if you do A, B, A, so this is false. The C is true, containing the pattern BAB. So if BAB is there, so can you generate anything other than A? Alright. A, B, B, A, B, A, B, B, A, B, A, B. Okay. A, B, B, A, B. Oh, wait. Actually, from here, instead of coming here, if you go here, what will you get? A, B, B, A, B, A, 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 B, B. So here this pattern, but if you have BAB, you need to accept it. Even number of B's. 1, 2, 3, 4, 5. No, because there is a loop, you can always generate a odd number. So this is false. Yes, this is true. B and C. Alright. Yeah. So the set of all strings containing the pattern BAB. So if you were to prove, if you got the pattern BAB and still cannot accept it, BABA contains BAB but not accepted by DFA. Okay, so it's not repeated pattern. You solved it 90% almost. Consider a finite state machine with one input X and one output F. Okay, given transition table. The minimum number of states. I have learned minimization. I have learned minimization. With one output, and so if A is given 0, it goes to F. If A is given 1, it goes to B, and B is given 0, it goes to D, and if B 1C, Alright. C0F, C0F, C1E, D, D0G, okay, D1A, my bad, D1A, E0D, E0D, E1C, F0F, F1B. Okay, you gotta draw arrow diagram, arrow marks. Oh my god. A to F1, B to DC, C to FE. Oh my god. D to GA, E to DC, F to FB, G to GH, H to GA. Okay. So this is the transition diagram. I mean, nobody cares about it though, but I just wanted to draw this. That is the transition diagram, by the way. Yeah, I uploaded it already. So DC and DC, so they belong to the same equivalence class, and GA, okay, so DH can be combined. Same transition and output. I guess what I studied is different. Anyways, that is question number 49 for you. And who's this guy? G1 and G2 are context-free grammars, and R is a regular expression. R is a regular expression for a grammar G language. Decidability. We already did this one. Duplicate. Question was already asked. So can you flag it? I don't know. Which one of the following regular expressions is equivalent to the language? Yeah, I should be able to do this one. So you can have any number of zeros that is followed by 1. So 1, okay, 1 followed by any number of zeros, and 1 followed by any number of zeros followed by 1 and followed by any number of zeros. Yeah. So any zeros followed by 1, and after that you can have, if zeros, any number of any, alright. So you can have 1 followed by any number of zeros and followed by 1 any number of zeros and another 1, and this pattern can repeat over and over again. And yes sir, D is your answer. Right. Oh yeah. You can't loop. Okay, I need to know this one, and after that, we will sleep, people. You can look through the final accepting state. The accept strings that are understand the DFA precisely. Start non-final, final double circle. Okay, self loop. Q1 to Q1 self loop. On 1, Q0 to Q1. Q1 to Q0. Key invariant. State depends only on parentheses of 1. Okay, even number of ones means it will end up in Q0, odd number of 1 zeros. So language is any binary strings. Alright. So any number of zeros and first one q0 to q1 now and count 0 stay in the same state 101. So it is saying like 0 go to 1 and have any zeros and come again to 1 and loop any number of zeros and go again to 1. Zero, 1, okay. Or union, concatenation, repeat. So, what it is saying is, so according to this language, 0, 1, so 0 and 1 have any zeros, we will stay here. Okay, 0, 1, 1. Okay. But this only allows even number of ones, alright. Nice, right? And I wanted to sleep now, people, and